Hello everyone, so today we are going to do Leetcode daily challenge. Construct target array with multiple sums. So in this question we are given with a target array and we are required to construct this particular array. And here the question is all about that can we construct this array or not? Basically, can we construct this array if we start from all ones? So that is the thing which the question requires us to do. So you are given with an array target of n integers, right? From a starting array consisting of n ones, you may perform the following procedures. So basically that is the thing. They want that if 1 1 1, basically n ones are given. So can we construct this particular array or not? So this is the thing they want us to do. Now, in that context only, what they have written in question is that let x be the sum of all elements currently in your array. Choose index I such that that index is positive index and it is less than n, or it could be even 0, means the first index of our array, and set the value of array at index I to x. So here they are just suggesting a procedure that we could follow like this also, that if x is the sum of all the elements in our array, then we can replace any number which is there at the indices with that particular sum. You may repeat this procedure as many times as needed. So we are required to return true if it is possible to construct the target array from array, otherwise return false. So the thing here is that the procedure which they have given to us, that we are required to get the sum of the elements at a particular step, right? The way they are doing here. So we are having all ones, so sum of it would be 3, right? So choose index 1, so we are choosing index 1, so because we were having here as that 3, right? So we are choosing index 1 and we are directly replacing that 1 with the 3, and now the sum is 5. So we are choosing index 2 and then 9. So this is the way they want us to do. But the thing is that we can do this question other way around. Basically we would be using the sum that all this, or means at particular instance we can do the sum of all the elements. We can use that thing also. But the thing is we can do this like this, that rather than going from 111, means basically n times 1 to 935, we can go from 935 to 111. We would be now doing like this because this is the one which is given to us as our input, right? So that's why we are just trying to figure out that can we do like this. So how we would be required to do now, that's a question. Before proceeding, let us take the constraints given to us. So basically the constraints are that if n equals to target, here n is equals to target dot length, target that is our array. So our n could be 1 also, and it could reach till 10 to the power 4. So this would be represent that we could also go ahead with n squared solution, and then at target of 5. So the numbers could be as bigger as 10 raised to power 9, right? So that's why we are required if we are summing up, right? So in that context we need to take care that we either take long or we take unsigned integer. So that is the scenario which this particular constraint is helping us to go ahead with. So now let us check for the fact that how we can do this question. See, we are planning to go from target to our 1 1 array, right? So the thing which we can do is, if we do something like this, means we are given with 935, right? So if we sum up all of them, right? So what we will be getting at that particular point, 9 plus 3 it would 8, and then 9 and 8 plus 9 it would be 17, right? And then if we take out the maximum element, which is 9, and if we subtract that, right, so then we will be getting our 8, right, and our maximum element is 9 here, right? So next step which we can do at this particular point is basically we are required that wherever I was having this 9, I just need to replace it with 1, right? So we are required to do things like that only. So then we subtracted that, right? Then what we are required to do is then we can do modulo with our sum, right? So then we will get 1, and thus whatsoever is there, we can simply store that particular element in place of this. But we can store only when we get 1, else we are required to move ahead with our solution. Like, I know this won't come up intuitively if I go ahead like this, but let me better explain the algorithm which we can use here by directly using the priority queue. So what we would be doing here is, we would be directly first adding up, we'll add up all the elements the way I was adding up this. Then we will push all the elements to our maximum heap. Why we are using here maximum heap? So that the thing of getting the maximum element, at that point also we were required to get the 9 from all the elements, right? So that purpose is being solved by the max heap. Now this is the main algorithm which is required. Now the thing is that we would be popping out all the elements from the max heap until we encounter 1. See, max heap would be having the maximum element at the top, right? So that's why if the top element is 1, that simply means that either there is only one element left or all the elements which are there, it is 1. So that's why if it becomes equals to 1, then we are required to get out of our loop, and at that particular point, what we would be doing is, we would be directly returning true. Because if all the elements are now 1, which is the desired, because we require 1, 1 at the end only, right? So at that particular moment, we would return true. So now this is the algorithm which we are required to do here. So first what we would be doing, we will pop the top element, which would be our maximum element, because in max heap the max element is being stored at the top. So we will store that in our maximum element variable. Then we will subtract from the sum. Basically we'll subtract this max element from the sum, the way I had shown you earlier that I was subtracting that. Then we will get a new sum, right? Now comes the next part, that at this moment only we are required to check that if our maximum element is less than equal to sum, or sum is less than 1. If our sum is less than 1, right, means basically negative. If our sum is negative and we don't need any element in our priority queue, basically in our answer, which is less than 1, because at the end we just need 1 in our array, right? So that's why we need to keep a check that if sum is less than 1, or if our maximum element is less than equals to sum. Basically why we are checking this is because rather than subtracting again and again same element from our maximum element, we would be doing modulo, so that at one step only we would be able to subtract all the elements. So that's why what we are doing is, we will check that if our maximum element is basically less than or equal to sum, then we will return false. Because see, if we are having 2 and if we do modulo by 3, then what would be the answer? 0, right? And we don't want 0 in our answer, we want 1, right? So that is the condition, we are checking this condition. So if this happens, then we are required to return false. Now after checking this particular condition, we'll do modulo, right? We'll do modulo, and in this modulo what we are doing modulo of maximum element with our sum. Basically this would be the sum and this would be the maximum element. So if we do modulo, then it would be 0, right? So this condition we don't want, that's why we were returning false. If this condition is not there, right, then we'll do modulo, and our new maximum element would be say if we are having this 3 modulo 2, then our maximum element would be 1, right? So this would be our new maximum element. And then we will add this new maximum element to the sum. Because see, if we were having that 935, right? So we have basically picked it out and we are having now 3 and 5 only. So the sum would be 8, right? So now we are obliged to add this new element, that is 1, to our sum, because at all the moment we are required to add all the elements, so that we could easily figure out that are we able to add up and then basically position a particular element to that particular position. So that's why we are adding up that particular new maximum element to our previous sum, so that we could get 9, and thus means not aiming at 9, but we could get the sum of all the new elements, because the new elements would be now as 3, 5, 1, right? Basically in priority queue we would be having all these new elements. So we will push our maximum element only and only if it is not equal to 0. So yeah, presently our maximum element is not equal to 0, right? It is equal to 1. So that's why we will push that into our priority queue, as we will push the sum. So for this instance, I'll show you both of the test cases. But presently I just want you to understand this algorithm. So that's why I'm doing like this. So this would be the thing. And when we will exit this loop, then we will directly return true, because it was a success. Because if it was not a success, then in that scenario, what the thing would have been, then it would have been returned false at this third step itself. So this is the scenario here which we had encountered. Now let me show you one dry run case so that it could be much more clearer. So this is the scenario. 1 minute. So here is the example. So in this example, I've taken the first example itself. So first the sum would be 17, maximum element would be 9, that is this one, and the elements in the priority queue would be like this, 3, 5 and 9. So the sum would be 8, and this sum come up when we are subtracting that 9 from our whole sum, because we are required to do that, and then our maximum element would be 1. This maximum element comes up after the fact that we do 9 modulo 8. So then this maximum element comes up. So yeah, presently because we had already popped out 9, so this 9 won't be here in the priority queue. Now next step would be that our sum would be 9, and in the priority queue we will be pushing our maximum element because it is 1. So now our priority queue becomes something like this, and this sum comes up after adding 1 to it. So now it becomes 9. Now we get maximum element as 5 after this new priority queue elements which are being there, because 5 is the only element which is being bigger there. So after that, this sum, right, will directly do modulo of 5 and 4, and we'll get maximum element as 1, and then add this maximum element to our 4. So now it becomes 5. Now we'll push that maximum element, basically this one, to our priority queue, and now priority queue becomes something like this. So after this, what we are required is, then we will get our maximum element 3, which would be something like this, and then our sum would be basically, we will be we'll get this particular maximum element. And now next, what we have done now is we have simply subtracted 3 from this 5, so we get 2 in our sum, and then our maximum element becomes 1. How it becomes 1? By doing modulo, right? And then it becomes 1. After that, we add this particular new maximum element to our sum, and then now new sum becomes 3. So then we will be directly pushing this maximum element to our priority queue, and then our priority queue looks something like this. All ones are there, right? Which is the required result, because they wanted us that n number of ones should be there. So yeah, it is possible, and top also becomes equals to 1, right? So that's why we will exit and return true in this scenario. Now comes the next part, which I was saying that when we are required to add up that sum to our priority queue and not the maximum element. So here 8 and 5. First we will add up them and then we'll get the maximum element as 8, and then priority queue would be having 8 and 5, and then the sum would be 5. How it becomes 5? After subtracting 8 from this sum, and then our maximum element becomes 3. How it becomes 3? After doing 8 modulo 5, so it becomes 3, right? And as the 8 was popped out from the priority queue, so our priority queue is having just 5 in it. And then as sum becomes 8, it becomes 8 as we add 3, that is our maximum element, to our 5. So now sum becomes 8, but at the last we are required to push our maximum element because it is not 0, right? So that's why we are required to push that maximum element to a priority queue, that is the 3 would be pushed, and at this particular moment, internet issue. So basically we would be pushing that there, and then after that it will be like all of them would be okay. So at this particular moment, our 3 would be added to our priority queue, right? So what we, next would be there is something like that. Now our maximum element would be 5, right? So it is 5. We'll subtract that maximum element from our sum, so it becomes 3. And then we'll do modulo. After doing modulo, what would be there is that maximum element was 5 and we are doing modulo. So it becomes 2, right? So after that, as we had already popped out 5, so now we would be having 3 in our priority queue, and now maximum element becomes 2 as it is not, and then we will be adding this 2 to this particular sum, so it becomes 5, and then priority queue would be 2 because it is not equals to 0, so 3 and 2 are there. Now our maximum element is 3 out of them, right? And priority queue have just 2, and then our sum would be 5 only, we have taken from previous one. Now this what we'll do modulo of our sum and maximum element. So after doing modulo, we'll get 1 and we'll subtract this new maximum element from our sum, right? And then after basically we had earlier subtracted the previous maximum element and then we got this 2, right? And then after that we'll add this new maximum element which is there, and so that it becomes 3, and then we'll push this particular into our priority queue, and then now everything is like 1 and 2 is there. So now 2 would be the maximum element and sum is there 3. So next we'll do modulo, so it becomes after doing modulo, so still 2 would be presently not done the modulo, so that's why it is 2, and then we'll subtract 2 from the sum, so it becomes 1, and after that what we are doing is we are doing modulo, and when we do modulo it becomes 0, and then we are adding to our sum, so it becomes 1. But now as maximum element is 0, right? So this is the condition that when maximum element becomes 0, then we are obliged to push our sum to our priority queue. So we just push the 1 and then we got 1 1. So basically we got to a required result, that is n1. Basically here n is 2. So here also we will return true as answer. So now here the time complexity would be order of NlogN because it marks we are already pushing n elements to our priority queue and n times we are doing this operation, so NlogN. And space complexity is order n because priority queue is storing at max n elements. So now let me walk you through the coding part of this particular question. So here is the coding part. So the thing is that what we are doing here is we have taken this priority queue. By default, C++ provides us with max heap. So that's why I have taken the default priority queue itself, and then I have assigned this unsigned int sum as per the constraint. We could also use long int here also, but unsigned also provides the specified range, so that's why I have used unsigned int sum here. Now next part is that all the x in my target I'll add up to the sum and then push that particular x to the priority queue, and then this particular that while my priority queue top is not equals to 1, then in that scenario I'll check for what is the maximum element and then pop out from the priority queue because now I no longer need that element, and then I'll subtract that particular maximum element from my sum. This is the first thing I would be doing, so that because I've already removed that particular from my priority queue, right? So that's why now I no longer need that particular element. So that's why I will remove that element from my sum also, and then I'll check that if my maximum element is less than or equals to sum, right? And I've already told why I'm doing this particular is because of the fact I need to do modulo. So in that scenario only, I'll check that if my maximum element is less than equals to sum, or my sum is less than 1, then I'll return false. Basically, if my sum becomes less than 1, right? Basically, if it becomes negative, then that is not the required result we need because we need 1, 1, 1, right? So that's why if my sum becomes less than 1, then I'll return false, or if my maximum element becomes less than equals to sum, then also I'll return false, because if I see if the thing would be either I do modulo with this maximum element or I would have been doing this, means maximum sum minus sum. This is the thing I would have been doing, but rather than doing so many times, rather than subtracting sum so many times, I just directly did this modulo from this maximum element, basically maximum element, and that's why I'm checking this particular condition here. Now comes the next part, that whatever new maximum element would be there, I'll add up that to my sum, and after adding that to my sum, because this is the new element which I would be pushing into my priority queue, right? Because it is still available. If it is not, then I'll push sum, because the one which I had showed you, the second example which was there. So that's why I need to keep a check that if my maximum element exists, means if it is greater than or equal to 1, then I'll push that, else I'll push my sum. So at the end, if this particular while loop has been completed, then I'll return true, else it would have been returned false at this moment only. So this was all for this particular question. If you have any doubt, you could comment that down, and thank you.